In this video, we are going to learn about how to create a schematic symbol and PCB footprint of 5-volt relay module. Hi everyone, I am Vaibhav Sugandhi, co-creator at Linked Frequency. This video is divided into 4 important parts. First one is downloading the proper datasheet and understanding how schematic symbol and PCB footprints are designed in that datasheet. Second step is creating a schematic symbol using EasyEDA. There we are going to follow the IEEE standards and the user perspective or user interface as a priority. The third step is to create a PCB footprint using EasyEDA, following the IPC standards and again a dimensional Cartesian geometry with respect to the datasheet data. Last but not the least, fourth step is to combine schematic symbol and PCB footprint to create a component library so that you can use it in your future projects. So let's get started. I have downloaded the datasheet from internet with a company name of Good Sky Electric Company Limited. Of course, it is a Chinese made product and this is so-called sugar cube relay in market most often. Why? Because maybe it is a brand name, I'm not aware of that, but it looks like a sugar cube. That's why most of the people call it as a sugar cube relay. However, in this datasheet, what we are going to do is we are going to scroll it down and identify the dimension section. This entire datasheet is just a 2-page of datasheet because it doesn't contain much detailed information of this particular relay. After all, it is just an electromagnetic switch, so that's why they have not given anything much in detail. All the necessary details are given in this datasheet, which is essential for the designer. But the most important thing that we are looking right now is this one, the schematic symbolical representation of this component, and also the footprint detail, the dimensions using a Cartesian geometry and all that thing. So first thing first, what we need to do is we need to identify this one and design it in schematic symbol section. So let's head toward the EasyEDA and start with designing the schematic symbol. Right now I am on EasyEDA platform and here I'll go to the file section, go to the new section and start with the symbol activity. First thing is I'll bring 5 pins which are essential for this entire schematic symbol. First one, second one, third one and fourth one and fifth one. Now before numbering them or placing them, I'll identify which pin is considered as which pin. Probably in schematic symbol they have not given any specific number to a specific pin. Pin number 1, pin number 2, we can name it however we want it, because it's very clearly known to everyone that the COM pin or the common pin of the relay is always at the side of where the coil is. Coil ka L1, L2 or maybe I1, I2, we name it however we want it. Those are the place where the COM pin is. So what I will do, I'll consider one pin or the pin number 1 as an in 1, which is input 1 for the coil actually, and pin number 3 as an input 2, in 2, because that is the coil number, coil input and the ground pin actually. So second pin, I'll call it as a COM pin, which is a common for single pole actually which we have, and the fifth pin I will call it as NO because normally open is on the top side, so I'll call the NC because fifth pin should be on fifth pin is on the top side, so that's why fourth pin is going to be NC, which is normally closed. So once we are done with that, we can give an electrical property to them, but this one is not having any specific electrical property. That's why I'm not going to give any electrical property to it. However, I'll arrange them as per I need or as per the user perspective or user interface. So what I will do is I will select a COM pin somewhere here, I'll place it somewhere here, and I will move these NO and C on the top side. So I'll place in 1 somewhere here, in 2 somewhere here, which is a 2 grid away from the x-axis, 2 grid away from the y-axis as well. So from the origin it is 2y2 grid away, and this one I'll place it somewhere in the 3 grid place, and NO should be somewhere on the 2 grid place, and NC should be on the 4th grid place, right? 2 and 2, 4th grid, correct. This is how I'll place the pins actually. This one looks good to me, but if you feel it is not so good to you or it is too much congested, you can move them however you want it. Choice is yours, choice is always with you. You can move it however you want. So 1 grid away from the in 1 pin, so I'll make it this one also like this, so that we can design some kind of a representation on that side. So once placing the pins are completed, I'll save the schematic symbol first because that is the first important point. Now what I will do is I'll name it as SPDT relay actually. Why? Because it is a single pole dual throw. So what I will do is I'll just scroll up a little bit and read these description and understand whether it is SPDT or not. I believe it is SPDT because it's very clear. So what I will do, I'll write it as a SPDT underscore relay underscore 5 volt. This is how I want to name my schematic symbol. Supplier part number, again, if I scroll a little bit down here, I can see the supplier part number. This is how they create a supplier part number. And I have to study and understand this one. RWH is the choice we have. I'll consider RW at this point of time, and then we'll give a hyphen. And after that, if SS is mentioned, it is a flow solder type, and SH means plastic shielded type. I think plastic shielded type is something what we want. So SH is my next name. Okay, RW hyphen SH, and then we have a single pole, one pole, and voltage has to be mentioned. Okay, let's call it as a one pole, single pole, how it is 1. Okay, and after that it is going to be voltage. So I'll mention a voltage as a 5V, which is a 5 volt. The next what we have, coil type, D is the standard one and M is also standard one. So I'll just go with the D. Hyphen is necessary, not necessary, D and M. This is how our the part number is selected. So once that is done, we need to head towards the manufacturer name, which is very known to us, that is Good Sky Electric Company Limited. I'll try to copy and paste it directly if it is possible. Yes, it is possible. That's a good thing. And then we have a manufacturer part number. This is a supplier part number. No, it's not supplier part number. Manufacturer part number is something here. So in the split section, I'll write it as a relay. And description, it is a single pole dual throw relay, single pole dual throw 5 volt relay. That's it. Okay, and after that, our trick, my name, Vaibhav Sugandhi, right? So this is how we are going to save this entire SPDT relay. And once that is done, what is our next step? We need to reduce the grid size to 5 and snap size to 5 so that we can design the user interface or representation of an electrical component in whichever way we want it. So I'll use this tool to create the coil kind of a structure here. How do I do that? This is how I do it. I hope you are aware of this one. If not, it is very simple actually. It's just clicking on the edge of the grids and you're done. So this is how I design the coil part here, and I will use the line tool to join that coil to the pins, whatever we have. So I'll just join it just like that. Oh, it has only one grid and this has a 2 grid. So that means this is not correct actually. I'll create a one more, this one is here, and then I will use a line tool and create it. Then I will add a one small line here that indicates it's isolated. And then we have a COM pin here. So is it possible to move this COM name somewhere at the bottom or somewhere? Just like this. Is it possible or not possible? I think it is possible, but not recommended actually. But still, we'll do it because we want a very good user-friendly design rather than making it a little complicated. So by doing so, I can move this pin. Very important thing. You should not move the pins when the grid size is 5 or maybe the snap size is 5. So make sure that you change these two things to back to normal, how it was earlier when you started, and then move it. So I'll just move this entire pins to a little inside so that we can create a better interface between them. And then again, I'll change the grid size to 5, snap size to 5, not 6, 5. And here what I'm going to do is I'll extend this one to till here and NC. So NC is normally closed, so I'll keep it there. And this one indicates the connection. So I'll just make this one just like that. Alright, so this is what I have done. I have moved these pins a little bit away from the placement where I have placed it, and I have increased the size of these black colored lines that I have drawn, and also I have increased the length of the pin itself. You can increase the length of the pin in case of such requirement. Like just say I have selected a normal pin which I placed normally, and that pin has a length of 20 mils. If we want to increase it to a little extra, like 30 mils, we can increase it, not this one, 30 mils, because I just wanted to make sure that this COM name should be sitting properly on that particular pin length. Okay, that's why I have increased the pin length to 30 mils, and I have adjusted the entire design according to that. This is how the entire schematic symbol looks like. Though it is not exactly aligned in the middle, but it looks better to me. But if you want to make it aligned in the middle, then obviously you have to change the snap size to 10 and then grid size to 10 again, and then move it. Otherwise, do not move it actually, because it creates a lot of problem to you. I think this one is looking good enough. It is not at middle actually, but that's fine. I'm not more interested to make it in the anchoring it in the middle itself. It's important to make sure that the entire representation of that particular symbol is correct enough. That is how we need to design this particular schematic symbol. Now it's time to head towards to the datasheet and understand the dimension of mechanical placement of the pads and the drill hole and everything. So let's start with that. Alright, so the distance from this particular pad or the entire relay's footprint, we will be using a Cartesian geometry here. I hope you remember how we designed our previous footprints using a Cartesian geometry. If not, please watch that video and understand them, and then come back to this video so that you will understand it very easily. So first thing is, we are going to draw a middle line here. It's not a straight line, but still you can consider it as a straight line. And we are going to create a middle point here. It's not necessary that we need to anchor this entire footprint at the middle itself. If you can do that, that's amazing, and that's the professional way. But it is not necessary. It is like overkilling actually. Instead of that, what we can do is we can focus on the dimensions properly, so that when you manufacture this on the PCB, your component will sit on that particular PCB and easily solderable. That is more important. IPC standards are more important. So that's why we are very aware that this dimension and this dimension is very clear, which talks about what is the distance from this point to this point. So whatever the distance is at this point to this point, it is 6 mm, which is very clear to us. Now, what about this distance actually? So from this point to this point, what is the distance from this pad or the pad from this origin or this point to the midpoint of the x-axis or the origin of the x-axis? That is given by this data actually. You can see here 12.2 is the total length from this point to this point. It is not a total length from this point actually. It is not the complete length of the entire product. It is only the length from this point to this point. If I divide it by 2, which is going to be somewhere around 6.1, so that 6.1 is going to be here. If you consider the midpoint with respect to this point, and this point, and this point. If I'm considering this as a square circle or a square rectangle, then in that particular place, this is the origin point. But this one will become a little extra than the origin, which is okay for me, because I know the distance from this point to middle of the x-axis, which is this distance, is 6.1 mm. And for that, I will add a 2 mm, which is extra they have given for this extra pad, and make it as a 8.1 mm from the x direction, which is minus 8.1 mm. With respect to y direction, this is going to be a 0 actually. Why? Because it is on the origin. That is the coordinate for this particular pad, and coordinate for this one will remain same with respect to the Cartesian geometry. So coordinate for this one is going to be how much? With x direction, it is 6.1 mm. Y direction, it is going to be 6 mm. This is how a square it is. I hope you understood the point. Now let's jump into the EasyEDA and design the PCB footprint. Here we are back to EasyEDA. I'll go to the file, go to the new, and create a footprint section. So first thing, I'll take all the 5 pads in order with the design of schematic symbol. So if you go to the schematic symbol, first pin is our input coil input, and a second pin is our COM pin. So what I will do, I will place a first pin here, second pin here, third pin here, and fourth one is here, fifth one is here. Fourth one is our NC, which is normally closed. So I'll just make sure that which pin is normally closed. You can see the bottom view of the schematic symbol. This one is normally closed because the COM pin is connected to it by default. That's why it is normally closed. And this pin is normally closed. So I'll just make sure that the pin which is named as NC is a fourth number, and on the footprint also the fourth number is lying on the same place. That is important. If you exchange them with the fourth pin to fifth and fifth pin to fourth pin, your entire design is going to be wrong. It is not technically wrong, it is a logical wrong. So that's why make sure that you maintain the numbering and the naming properly. Now what I will do, I will place this particular pad in the middle. It's already in the middle, just I'll ensure that Y-wise it is 0, and X-wise it is already known to us, which is all about how much, I think, this one. So X-wise it is minus 8.1. So what I will do, I'll just go back to my EasyEDA and I'll select it and I'll name it as 8.1 mm. So this is at the place, okay? And then we have this particular pad, I'll select it and I will change the X direction as a 6.1 if I'm not wrong. So I'll just go back to this one and enable this part, which is this one. So it is 6.1 with respect to X direction. So I'll come back to EasyEDA 6.1 and the Y direction it is 6 mm. And similarly to this one, which is X direction is 6.1 and the Y direction is going to be minus 6 mm. And with respect to this one, minus 6.1 because it is X direction, and Y direction it is 6 mm. On this side it is going to be minus 6.1 and also minus 6 mm. This is how we need to place all of these particular pins properly. Now after that, a very important thing to be considered here. What is the drill diameter and what is the pad diameter, which is again given in the datasheet. You can see here these coil input pins are pretty small, which is 1 mm drill hole should be given to them. And pad width of that particular pin is choice to you, which is better to give a double or more than double. So I'll select these two pins and pad width I'll give it as a 2 mm and the drill width as 1 mm. You can give 1.6 also, choice is yours. I feel we'll go with a 1.6, which is very standard in PCB designing. But this COM pin and also NONC pin, they handle the high current and high voltage with respect to the power delivery of whatever load we are going to connect. So that's why they need to be little thicker and little bigger. So how we need to do that? We will create a pad size of 2.5 mm, which is absolutely good one. You can make it as a 2 mm also, choice is yours. And when it comes to drill hole, it is clearly given it is 1.3 mm minimum. So I'll give a 1.5 mm so that it becomes easy for the soldering process, and we can place the relay very easily. Or we can create a 1.4 mm also. Choice is yours, 1.4, 1.5, 0.1 mm tolerance is okay for all of these things. This is how our footprint pad position to be done. This is only with respect to pad position. What about the creating the aesthetic look to that? That one we'll do it now. Before jumping into the creating of aesthetics of this particular footprint, we need to save it, which we have forgot. So we'll save it first. Now we can save it exactly the same name as we saved our schematic symbol, which is a choice because the schematic symbol and the footprint both are similar. There is no specific name to this particular footprints, like how we had a specific name to the dip ICs like C-dip and P-dip and all that thing, generic name. But this package is a very specific or very linked to the schematic symbol that we have designed. So I'll name it as a DP SPDT, not DPDT. So SPDT RELAY, relay. I'll just name it like that. Not necessary that I have to give a detailed name or 5 volt and all that thing. So I'll just name it as a SPDT relay. And in description, tag is obviously a relay because it is a section of relay only. And in description, I have given single port dual through 5 volt relay my name. I think I'll remove the 5 volt because this particular footprint can be used for 12 volt relay in the same category. Possible, right? Because in datasheet, we can see that this particular relay is available for 3 volt, 5 volt, 6 volt, 9 volt and up to 48 volt. So whichever relay you take, the same footprint applies to it. So that's why I'll make it as a generic one, and then I'll save it. Alright, now we are done with placing the pads on the PCB footprint. It is time to identify and understand how to create a border for this relay. There are several ways to do that, but one way which is essentially need to be followed as a professional PCB designer is to use a Cartesian geometry again. You can simply use a rectangular tool and draw along around this particular pad and create a square or a rectangular box, which is absolutely fine, but I prefer to go with the datasheet information. So if you go to the datasheet dimension section again, you can see the total length or the width of the entire the relay body itself is 19 mm. And with respect to the length of that particular body of the relay is going to be 15.4 mm. Now what we will do is, we are very sure about the width part. Why? Because we have all these pads which are aligned to the center of X actually. X axis is being the center, or the origin part is being the center with respect to along with the Y axis. That's why we'll use the height detail first and length detail first and create two lines on the other two sides. First thing is 15.4 mm. So we are going to divide a 15.4 mm divided by 2 because we want to make sure that it is at the center. So it's 7.7 mm. So what we are going to do is, we are going to go to the top silk layer and use a track tool and create a random track like this, just like that. And when we select that, we have a stroke width which is going to be 0.254 mm, which is absolutely fine. And then start X is going to be, what is the start X? Again, that is also a very important point, which I'll come later. The start Y is going to be 7.7 mm and end Y is going to be minus 7.7 mm, which is the total the height of the entire sugar cube relay we can consider. What about the distance from this pad to the edge of the body? Or what is the distance of the edge of the body with respect to the origin or the center? That information is available here. You can see the pin of that particular relay. From that pin to the edge of the body, plastic body, is 3.4 mm away. So what I will do, I'll select this particular pad and see what is the distance from the origin of X-axis. So with respect to X-axis, it is 6.1 mm away. So what I will do, I will add a 6.1 mm with a 3.4 mm, which gives me a 9.5 mm. So this entire line or the body is 9.5 mm away with respect to the X direction. So what I will do, I'll enter it here 9.5, and this one is also going to be 9.5. Similarly to this one, I'll create one more line on the other side. So I'll just draw one line here, select it, make it X-axis as a 9.5 because we know it is 9.5, and end X is also 9.5, but with respect to Y-axis it is 7.7, and end Y is also going to be minus 7.7. So this is how our the left side and the right side line should be done. This indicates the body of the entire relay. Now the next part is adding the top side and the bottom side, which you can do by using a Cartesian geometry the way how we did it for both the sides. But my choice is to just select track line or a track tool and join these 2 points very carefully. You should join them from the end point only. You should not drag it from any point that you feel comfortable. And when you select that particular point, this is the beauty of mathematics and a Cartesian geometry. When you select that particular point, you can see the total length of that particular edge is going to be 19 mm. And that 19 mm is what given in the datasheet. This is how easy it is to create a schematic symbol and a PCB footprint with respect to Cartesian geometry. Why we need to use a Cartesian geometry? For this reason only. Dimensions are going to match accurately. Now I will draw the same line on the other side as well, just like this, and we are done with creating a PCB footprint for 5-volt relay. Once we are done with saving this particular footprint, we need to identify or understand these custom properties once again. The first thing is, it is having a footprint name properly given. The prefix of this particular footprint should be changed as RL. RLY is something which most people prefer to give, so I'll give a RLY as well. Again, in the schematic symbol also, we have to change it to RLY question mark. So footprint, we will assign it right now, but once we are done with the footprint part, I'll save it and make sure that in both sides the custom properties are updated properly. Alright, when I'm saving this schematic symbol, there is a small logical error which is indicated by the software, which is absolutely amazing. You can notice that I knowingly or unknowingly I have moved this particular comp pin when the grid size was 5 actually, which is not good, but which is not recommended, not necessarily need to be followed, but I have moved it somehow. And when I save this particular schematic symbol, you can see there is a pop-up here. The pin com are not snapped to the grid point. This is amazing actually, which is absolutely a problem when you start designing the schematic symbol or a schematic using this particular symbol. So how we need to solve it? We are going to select this particular com pin and make sure that the grid is set to 10 mil and the snap size is set to 10 mil. And I will move this grid pin somewhere where it is need to be snapped. So now I snapped it to particular grid point and now I will save it. Now that particular pop-up error is not coming. That is how you need to pay attention to the details to the entire EDA tool, and it is going to help you. Now it is time to combine the PCB footprint and a schematic symbol to make a component library. It's very easy process. I'll go to the footprint section and I'll search for relay here, or maybe SPDT, whichever I have designed. Oh, maybe in my workspace I named it as a SPDT or SPDT, right? So SPDT, so I'll just select it for SPDT. In my name, I can see that SPDT is reflecting. So when I select that, you can see all the pins are connecting to each other properly. Just cross verify them once again by looking at the connection where it is going. So in 1, in 2 are going to the coil point only. That's a good thing. And COM pin is going to the middle in between those input pins, which is absolutely necessary. And that is the way it should be. And NO and NC. So NC part is on the bottom side, NO part is on the top side. When we look at the data sheet, that is how it is given actually. So just make sure that these things are matching. Once they are done, then click on the update footprint and the pop-up window will ensure that it is updated, and then click on the cancel and you are done with creating a schematic symbol and PCB footprint for 5V sugar cube relay. Alright. Now you have completed creating a schematic symbol and PCB footprint for 5V relay and created a component library which you can use for any project, for any of the application. I hope you enjoyed the entire tutorial and I believe you have created without any glitch. If you have any questions or any comments or any suggestions, feel free to comment down below in this video. See you again in the next video. Until then, tune yourself to make a difference.